Okay. This is just so beautiful. It just seamlessly changes solution as if it's. I mean, the blue one is one of these, and the what is it? Orange one is the other one, and they completely play together as if it's. I don't know. This is like a straight line. How is it possible that one of them? I don't even know which one is which, unfortunately. But let's say the top one is blue, and that one goes like here, and then it goes down, and then it goes straight again, and the other one is then doing that. And if you look at it as a human, then of course you say, yeah, duh, this is a line. And completely independent from that, we have that. Just like this one. Why do they swap? And see what happens if I change X value. No, they come loose. X slowly larger. Bang. It just goes a little bit too fast. Down the same thing. Oops. It just suddenly connects. Yeah, this is wonderful. What the heck is going on here? Definitely not two separate solutions. I don't know why it switches from one to the other, but yeah. The only way, though, I think that what happens here with blue is that it just gets complex, so there is no solution anymore. Probably because what is under the root becomes negative. But yeah, then exactly at the same moment that one becomes negative, the other one becomes positive, apparently. Or no, no, it's not true. That one also goes like this. This one, I don't know how far down it goes, probably to minus infinity. And then, oh yeah, of course, it goes down here to minus infinity and then comes back here. So this one is just going like this. It's 1 divided by the sinus of something. Then it comes here, and then both go negative at the same moment. And then here, at the same moment, they become positive again. I suppose that should explain why they have the same value also. In other words, they connect. Because if what is under the root is negative, or is going from positive to negative, aka it's 0, then there is no difference. It's just a plus the, what is it, cosecant. This is 1 divided by the sine of theta. And here we have the same thing. Both divided by 2a. So yeah, the value is the same at the moment that the root is 0. And what is under the root is also the same. Yeah. So it's not that weird that it switches from one to the other, I guess. The last thing that you could say is that apparently at that moment the derivative is infinite. Because not only are they having the same value, but also it's going vertical at this point as well as that point. And I guess also if you make exactly, I mean it has to be, you know, like it changes direction actually. Like, I mean, if you allow to connect, there's a little gap there though, but probably a round off error. So blue is just a function, and it goes infinitely sharp and then becomes complex because it can't go backwards. But then it's taken over by a function that meets it from here. Something like that. I think it's fascinating. Yeah, this is also very beautiful. The how on earth moment. I would like to see the complex value. The stupid thing is, it is 100%. No, yeah, Abhimanyu. I mean, this is 100% real, and only at this point it becomes complex. Yeah. And then it does something, and then here it becomes real again. What is it doing in between? Yeah, Abhimanyu, I've been doing. I've been struggling. Yeah, I've just made no progress, no progress. But well, I learned a little bit how to use Mathematica. This is Mathematica. That's going to be much more helpful, I think, than ChatGPT is at the moment. So I filled in the formulas. So the XT is this, or I just used ST for the sign, but well, it's just an abbreviation. So this is the parametric description of the curve with, well, a parametric description of a curve that is a rotated parabola that goes through 0, 0 and 1, 0. Yeah, and then I was wondering, I mean, I said here, solve it for t separately. Just first only looking at this one. Solve this one for t. And then the question is, my question was, which of these two gives rise to a negative t? Because I only want to look at negative t's. And I don't think it's very conclusive. Hi, Radio Sketch. I mean, for example, at this theta, there are two solutions that both have a negative t. How is that even possible? Okay, because I only have the x coordinate, right? It is. I guess it is possible that the leg of the parabola goes through the same x coordinate twice. Not just possible. I'm sure of it. So I guess that's what's going on there. Let me see what I have right now. So now I only draw the part of the parabola that is that generated by negative t. So t is minus infinity, and then we come here, and then t is 0 in p0, and then we stop drawing it. And for this case, you see that there is only one solution for every x value, up till 0. Values above 0, there's no solution at this point, but that is for yeah, whatever values I have now for a and theta, I guess. I think that was just theta 0 or something. So now I'm changing theta. Still only one solution for each x value. But if we continue far enough, then there is indeed a little bit here. There is a small region for x where there are two solutions, either this one or that one. Given this x value here, the little negative x value, there are two solutions with a negative t. Or this t is almost 0, and this one is yeah, a lot farther, so a lot more negative. So I guess that then the blue line corresponds to the solution close to p0. And then if you go down, then t is much more negative, and then we get the orange solution. Maybe I should make them match, right? So here I have an a value of 1.746. Let's code it in, and then we can compare it exactly. So this one was now for 0.8, 1.7, why can I not remember that? 64. And x value, x value I can just plot in, of course. So that's the only change that I need to make. Well, maybe not. Maybe let's pick. Let's pick this theta as well. So that's like 3.5, 3.6, but maybe too far. 3.5. I don't know, between 3.5 and 3.6. 3.55. So in radians, 3.55 radians, and then just the very first image that we get. Okay. And then the x value is minus 0.01. Very close to 0, so almost here. So yeah, that is a t value that is very close to 0. And the second solution is a little bit less than -1. So yeah, well, at least I put it here, right? Here, I would say that is like depends very much on theta, I guess. I don't know. From the looks of it, I would say -1 is more close to 3.45, really. I don't know. Doesn't really match. Oh, I'm an idiot. Sorry. Yeah. I'm looking at the Y value. I'm not even printing the Y value. So apparently we were here, right? So the T value here is like, I don't know, minus 0.4. Apparently T is minus 0.4 here. We don't know that. I mean, the T is more negative here, but you don't really know the absolute value. I know it's 0 here, negative here, but that's it. And then if we rotate it further to say, well, here, 3.8 radians, then there should be no solution at all. Looks like it. Well, I'm gonna guess that it runs like this then, or like this. So yeah, then there's, it's not going through this side, so also not through minus 0.01, the X value. 3.8, I said. Let's try that. Hey Devon, welcome back. Yeah, so in this situation there's just no parabola at all. I mean, it goes through this as well, so I'm gonna guess it goes like that. But there is no solution. It's not going through minus 0.01 here. But if you look at here, beyond 4 radians, there are 2 solutions again. What the hell? I'm gonna fill in, I don't know, 4.4. Okay, so there must be. Oh, wait a minute. Those are positive T values. So if we rotate it further, then the other leg. Oh, no. Yes, of course. Beautiful. This is between 0 and 1, this blob. So that means between 0 and 1. So that is this part of the parabola. And if we rotate it further, then this vertex of the parabola part rotates through here. So then you have 2 solutions here, and those are these 2. And I guess that if we rotate it this far, then we get 2 solutions again, because it's probably just going backwards like this. So we just rotate it all the way around. Let's try that one then. This is 5 point, it started at 5.8. Let me try that first. .8, because then I don't have to type more than 1 now. Yeah, it's immediately clear, isn't it? So now the negative T lag is indeed bending a little bit towards the negative side again. So we have already 2 solutions here. So it's definitely not really the case that it's either one or the other root, aka the blue or the orange one. Both are solutions here. Both are solutions with a negative thing, so they are on this lag. It just, what changes is the y coordinate. what I've been doing in the last days that I was not streaming, days, I don't know, is trying to, you know, add another point anywhere as third point. So now we have 2 points here, and we'll add a third point, and then figure out what restrictions that gives me for the A and theta parameter that I have now. So I did bring it back here to just 2 parameters, A and theta. And yeah, just failure, pure failure. Just did not figure it out. Something to think, is it not possible to plot it in here? I can also make a solution for, let's see, let's call this solution X. This can be removed. Backspace. This can be removed. And this can be removed. I'm gonna call this one TX1 and TX2 using the solution X and again the solution X. No, I forgot if I do shift enter or control enter. Shift enter again. Shift enter. But we want to have more, so might as well extend it. You can just add stuff here, that's all fun. The solution Y is then solve YT equals Y. Solve for T. Yep. And you have 2 of them. That one looks impressive as well. And then here I can add ty1 as a function of y and a. Oops. And theta is t with or using or whatever that means slash dot. Now we know where slash dot comes from. The solution of y, and then I guess 1 comma 1. I just pulled it out of my oops, I hit return, shift return, I meant this one. ty2 is y underscore comma a underscore comma theta underscore equals t slash dot sol y 2 comma 1. That's the other solution. Yeah. Now shift enter. And now we want to make a plot. Let me think. What kind of plot do I want to make? I think I just have to add another slider, namely the Y slider. which I guess we can also run from minus 4 to 4. And then we want to plot the both solutions, right, of the other one. So this is T1, T2, and you keep adding it, but this, what I renamed it to T1, TX1. Can I copy this? It says copied, so I guess that worked. And then we do a Y here. Let's see, so now it's going to plot TX1 and 2 and TY1 and 2. Using the values theta, which is part of the plot, so that's horizontal here. And we have 3 sliders, one for A and one for X and one for Y. Shift enter. Now, isn't it amazing? And you can click on it and then drag this. And then, of course, a solution means that both X and Y have the same t-value. And it must be a negative t-value. So now we see that there is only exactly one solution there. This is the only point where we have a crossing. So the t-value is negative and the same for both of them. This is the solution here. So I just know that for this A, X, and Y, that is the theta. How awesome is that? Now let's change A a bit. It doesn't even make that much of a difference. You know, A is not really much influence here. The other crossing here, by the way, is the other leg, the positive t. There's also only one solution for that. If we change X, then what happens? Oh, wow. Yeah, man. This is so beautiful. You can make a poster of this and sell it. Absolutely brilliant. Why does Y not have any influence whatsoever? Shit. Oh, because I'm passing the Y. Yes, thank you very much. This thing does not depend on X. Let's try that again. Okay, I can change X a little bit. Yeah, I can. You have to do it yourself. That's how it works. Hard work. I'm gonna do this Y here. I guess what I'm looking at is that there's only one point where they cross. So in this case, here. Now that's interesting. I see multiple solutions for the positive t. 2 here and 1 here. Well, X is almost 0. It's just too close, man. They're so close that you get the blob here. Oh, yeah, of course. These two are part of the blob, aka the values between 0 and 1. Ah, no, right. Sorry. We have to look at not just positive and negative, it's t less than 0 and t larger than 1. Larger than 1 is the other leg. This is in between them. That's not interesting at all whatsoever. So this is the one solution for one leg, and this is the solution for the other leg. And then we have 2 more crossings here near to the vertex or whatever. Let me make the x pretty negative and then the y a bit positive. So I adjusted it such that at theta 0 or 2 pi, we have the solution. Crossing is now exactly at theta 0. That looks like 1 radian, maybe a little bit more. Let's draw this one for fun. See what the hell this is. So I now have an A value of 1.38. And theta is 0. And the xy point was minus 0.71, so that's about here. And 1.68 up here, I guess. Again, this is the point here. So yeah, I don't know. I found this point such that theta is 0 is exactly the right angle. Maybe I should draw the rest as well. You just see a parabola here then that is standing right up. So we can also find one that is almost at minus a half and then 1. So we said x to minus a half and y to a little bit more than 1. That should also give a crossing at theta 0. Let's have a look. So this one is then minus a half. And this one is almost 1. Yep, that's about true. A little bit more, I guess. So yeah, no, something like that. Works for me. Okay, I think I'm starting to understand how this graph works. But, no but actually, it is clear that we always have green here. Green is always the one that we want to cross with. So now I'm going to play with everything. That cross between green and blue. And then we do this. It is a cross between green and blue. And then we do this. Cross between green and blue. A has no influence ever. Not hardly any. But these, very negative x, totally green blue, and then Oh, green, orange. Yeah, okay. And that happens when? Still here, negative x. That's not the reason. Now here I have a crossing that goes exactly through the point where it switches from orange to blue. What does that mean? What does that mean? Well, that means that, right, if you just look at the x coordinate, which is this curve, the actual solution is at the point where a vertical line, which has a constant x coordinate, does not have two solutions. In other words, then we have a solution that is in a point that is also here vertical, I bet. So let's say you have something like this, and then the solution exactly at that point. Meaning that if you make x a little bit larger, you have two solutions, and if you make x a little bit smaller, there is no solution anymore. So you can try that one out as well, see how that looks like. So that would be 4. A is 0.5. And theta, I don't know. It's a bit hard to see. .88. It's my guess. 0.88. 5.88. There is hardly a vertical point here. Nope, strange. The x coordinate here is -7.9, so that's about there still. 2 point, oh, that's way off. Okay, that's way off. So maybe it is running vertical indeed, all the way up there. We can't see it. Has to be. Has to be. Yeah. I could change the range, but well, maybe try to do the same thing here, but then with a smaller y value. Can I change x such that? Yeah, there we go. Whoops, not that. I don't know, something like this. That is a theta of 246. No, let's say 7.5. $5.75. And A is still 1.5. Oh. Yeah, I guess that it's vertical. Like, I think that's just going backwards here. It's not clear. Anyway, I'm gonna say yeah, good enough. So my point now should be a little bit less than a half and almost 1.5 for Y. A little bit less than a half for sure. 1.38. Yeah, I guess I didn't get my alpha exactly right. It's very sensitive at that point, of course. Right. Nou ja, all kinds of spielerij, maar got to actually make some progress, I guess. It's always nice to see that things work out, but still. How to continue this? Daphne is always the green one, huh? That says a negative T. It's a logical way to see that. Yeah. My A is always positive. Well, even worse, just divide this. Why is it printing it like that, dude? This is a half plus. No, okay. This square root. Only why the square root again. We could put the A in there. Would make more sense than put it as a square in there. It's gonna be simplified way. This is ty2. I think a simplifier works on that one. Let's try that. Simplify ty2. Oh shit, they cut off my unpaid license. I did take a trial a while back, and I didn't. I quickly gave up on Mathematica actually. And today I tried it again, and it still worked. I was like, what? They forgot to terminate my trial session. But this looks like, yeah. I'm afraid it was the end of the use of Mathematica. That kind of sucks because I was just going. Yeah, I was using this one. And then I really have to type this on stream. Where are we? Oh, no, what? No one knows where it went. Oh, here. No, also not. Oh, I did go here. Yeah, I did go here, sorry. No. It hasn't decided yet. Oh, we're back in. Or are we? Yeah, looks like it. And you have to reload everything again, which is really strange. I don't know why, but you have to reload it. And then we get back here, and it still works. I have new hope. Okay, so what was I going to do? Yeah, I was saying that I want to simplify that. Ah, right, that's what the S is still there. Even. Simplify. Can I click this? Yep. Simplify YT2. Isn't that what? No. TY2. And that didn't work at all. And did I reload these things? I think definitely did, yeah. But it does not want to do it. We can guess a few things here. Let's fill in the X or the Y, the A and the theta. As if, and then hit this again. Wow, yeah. The node comes up with a half. At least it looks different, but I wanted to. It's just so totally not optimal. Try harder. Nope, nothing. Kind of silly, I think. Is there no 1 divided by the cosine as a primitive? That's something ChatGPT knows. What happens if I just type what I think it should be? And then ask to simplify that. Is it still going to expand it to this this nonsense? So I think it should be. Let's say I'll call this. Optimized TY2, but it's not really the same. But whatever. A half plus the square root of. What probably have to type a capital S. And then inside I type. The top thing divided by the square of half, which is a fourth, times 4 is 1, so that's just y then, plus, and then we get, now let's type it in first, a cosine theta divided by that 4. But the whole thing has to be divided by cosine and a. So also both under a root. So we just divide by a cosine is theta, which makes this side 1. And this side becomes, yeah, what the hell? This side becomes divided by a. And divide this by a, so we had that done now. And then this side becomes 1. Oops. And this side becomes the sec theta. Yep, we divided by a, divided by cosine, and I divided by 4. All under the root. And then I typed shift enter and nothing happens. Okay, OTY2. Okay, got there. Yep, I guess that's what I did. Typed, said, whatever. And now if we do a full simplify of OTY2, does it corrupt it again or keep my beautiful... Yeah, it does. Nah, I don't understand it. I think this one is way simpler than that one. So, what the fuck? Duh! Duh! Well, I guess I made a mistake then. Or I'm very, 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 very disappointed. This should be 0 if it is equal. Why would that not be 0, man? Bullshit. Just the same thing. Why is this not 0? Can we plot this so you can see it? Bloody thing has a few variables though. Let's say that is half, and y is a I don't know 2 point that, and then I want to plot yeah. I could use percentage, but I'm not sure that works anymore after talking that. Yep, it is totally clueless. That looks like 0 to me, right? I don't know what happens here, but it's like 10 to the power minus 16 and floating point around of noise. So let's plot it between 2 and 4. to force it to show me what's happening in that part. Nothing. Or is it suddenly 2.34 here? What is that? No, that was the Y. You get an empty plot. The hell? Maybe it becomes complex or something. Is it negative at some point? Less than 1, I mean? Maybe that's the reason. Maybe that is the reason. So, but still. That would also be the reason that it doesn't want to convert it, I guess. Oh yeah, this is definitely negative, of course. This goes to minus infinity. Dividing, so for a range of pi wide, it's complex. And then there should be the same thing though. That should be the part where the cosine is negative. And it says I can't plot the complex part, but I can plot the real part of this. Aha, a 0, yeah. And it can also plot the imaginary part because that is real, and then we can plot it again. And that is not 0. I'm shocked. I am shocked. Okay, so it was almost the same, but not quite. The imaginary part is non-zero. In that area. What went wrong? Okay, we're just talking about the difference here. So we can still plot, say, half of it, and then we should get the same thing. If we just plot, especially since I'm only interested in where it is real, or it is real. So yeah, I don't even take the real part. Just plot the whole thing. And then, well, plot both things. Okay, so the thing is that oh, what was the other one? Oh, there. TY stuff. Yeah, those are on top of each other. The problem is just that it's not defined in this part. And they are differently not defined, I guess. You know, the one not defined is not equal to the other not defined. Or we just have to swap to the other root. Well, it's also very possible. Which that might solve my problem. What was I looking for anyway? Well, I was looking for a reason to say that only one of the roots is negative and the other one is never. And it totally looks not negative here. I think I have the wrong one. So this would be the plus. You always have to do the minus one, and that is the minus in front of the root. So why not plot? Let me redefine these things. OTY2 is defined here, so I want to have there a minus the root. And then we have the other one, it's just a 1, I guess. Oh, then I should not have redefined it, but who cares? Well, totally negative. I guess that's on top of each other, right? Blue. Yep. Why is that always negative? Oh, shit. New question. Can we clear A here or not? Clear A and Y. And then does that still work here? Here. That seems to have worked. And then I can attempt a full simplify, which didn't do anything. Well, actually, it made a minus here, I suppose. Good, good, good. Yeah, okay, it makes sense. Or does it? I mean, it makes sense if this part here is positive. Because then a quarter plus something positive, and then the square root of that is larger than half, making the whole thing negative. But why would this not be negative? Y could be negative, to name a random reason. So let's try that again. Negative Y. Still negative, but now in the middle. Ah, What? Don't get it. Why is this always negative? Why the hell can it not be a half? Surely this can be 0. Okay, this can be minus a quarter. Can't it? So 1, or the sec is 1 divided by the cosine, which means it's 1 divided by something less than 1. It doesn't matter. Damn it. Brute force values. No, I have something positive. But No more music. It's just one gent here. Have to do a times 10 there. Yeah, so if a drawer like this at P0 and P1 are always at the same place. This in the origin and this at 1, 0. Even if you rotate the parabola. But now I'm thinking about keeping the parabola straight up and then try it that way, because I don't know, I'm kind of stuck in this rotated parabola world. So we want to plot the whole thing we have now, but then rotate it, I think, clockwise by theta. And yeah, just real programmers do that using a matrix, I guess. So my result that I have here is an XT and a YT, and I just calculate them and add them. Okay, let's not use a matrix. I'm just going to rotate everything. Wait a minute. No, let's use a matrix. Also having a matrix here, or I'm using here, how what looks like pretty lame way. I don't know, maybe not yet. But then again, I'm going to say theta clockwise or just minus theta. So yeah, let's add a matrix, because otherwise I'm going to get knots. Let's create a thing like that. From let's stick to rho major. So that would be the cosine of theta, comma the sine theta, comma cosine of theta again, and then minus theta, minus the sine. And then I have to code a matrix. It is already colored, but I think that it's it's more my debug tensor for machine learning. Yeah, I can't use it here. Yeah, well, why not, you know. Let's create a new tab. Oh, that was a small font. Let me correct that as well then. Switch. To let's create a matrix.h. Pragma wants a namespace cairo window, and closing that again, and then class matrix, and that class is not a real matrix, it's a 2x2 matrix. And so we have private stuffs like double M00, double M row 01, double M row 1 column 0, double M11. And I constructed that as in the same way, matrix double M01. What am I doing? Double M10, comma double M11. Loop up, ping, boing. And the rest. So funny thing with copy paste and other methods, by the way, is that the way I did that, I cannot make a mistake. You know, I just copy it and I paste it twice. Therefore, this 01 always matches that 01. And then you save it and you commit it, and nobody knows how it was generated. So someone who was looking at this later and suspecting a bug has to go over it again. Like, does the 00 match that 00 and that 01, etc. So I feel that sometimes, I mean, I even use scripts, like really sophisticated ways to generate code. And then I feel very secure about the correctness of the code because the way I generated it. But anyone looking at it afterwards cannot have that same feeling because they don't know how I generated it. They might think, yeah, he typed it in character by character, so it could be full of errors. Just a side note. Maybe that's lacking in a programming language. It would be better if the programming language itself was such that robustness would stay in the language, if you understand what I mean. You could look at the code and then see the same robustness as if, yeah, you know, you would never have to do something like that. In other words, this should be more like matrix and then literally saying all the arguments. And then here's not type it all out, but literally say copy all the arguments, you know. So then you don't have to check it anymore because it just literally says what it should be in a way that you can understand as a human that is what is correct. But yeah, that way there are many ways. So you kind of need a meta language or pseudo language, a programming language inside the language to generate the code without actually generating it, making the generating code a part of the language. Now, what do we need? I can initialize it. Well, probably need accessors because you want to know what's in it, but I don't. So let's just do vector in, vector out stuff, I guess. Multiply the thing with the vector. Include the vector.h. And then, of course, I have points that I want to rotate, but I don't think I should allow my matrix to be multiplied with a point. You just have to convert the point to a vector first. My vector takes two of those, or a direction, or 2 points. Or this, but then it's explicit. That's annoying. I can still do that. So if you have a single point, I could say vector brace open and then my point brace closed. That would be explicit constructing a vector from the point, and then we can pass that vector to the matrix or whatever the multiplication operator here. Which then of course gives a vector out. And that then would be an operator. Yeah, why not like that? Vector const reference v. So we have a vector result. We'll return that. Ah, bullshit. I just fill it all in directly. Yeah, and then if you have a matrix, maybe I want to return a determinant. Determinant. This is const as well. And an inverse maybe. How do I make an inverse from? I think it's some juggling with the elements and then divide by the determinant. I forgot how. Let's ask ChatGPT. I'm sure it knows. So what is the inverse of a 2 by 2 matrix in terms of its elements and its determinant? It's pretty good at understanding what you mean. I have to give it that. So we swap this one cross and those, and then those all become negative as well, and then you have to divide it by the determinant. Oops. Yeah. Okay, matrix inverse const return. Yeah, I don't want to calculate determinant every time, but the division has to be done anyway. And I probably, the compiler would do this anyway, but yeah, you know, determinant, no, I don't know, I feel more secure doing it like this. And I just think it looks silly to call that function 4 times. So then we return, and then we have to swap the diagonal thing, so those two, and then those two as well. And the order is M0, so now we begin with that one. And then normally you get 0, 1, so that we get the 1, 0, 1. And then the next one is 1, 0, that would be then this one. And then finally you get the first one, obviously. And this one, those two must be negated. And we have to divide by the determinant everywhere. At least according to ChatGPT. So fingers crossed, but can't imagine it would get that one wrong. So way to quickly check it. I can just multiply this with that. So yeah, if you multiply this column with that one, you get AD minus BC, which is the determinant, and then divided by the determinant is 1, so you get a 1 here. And then that side is this column divided times that one, so that's again AD minus BC. Obviously, there's also 1 here, and for this one we get AB times that, so that is 0, yeah. And here as well. Very good. I'm saying that, but I meant this one, of course. CD times the D minus C, which is then CD minus CD is 0. Divided by the determinant is still 0. That's why I stopped at the 0. It checks out. That is the inverse. What else can we do with a matrix that I don't need? All kinds of operations. Negating it, multiplying it with a double. It's maybe the same thing, but the negating is slightly more precise if you just do it. No, it's nonsense. Faster anyway. It's not the 1980s anymore. What shall we do then? Just adding a multiplication with a void operator. Nah, come on. Let's at least return the matrix itself then. Operator, multiply this thing with a double, but yeah, we want, I think I would like to have the double usually in front of it. So this must be a friend then. So we can have the double up front and the matrix second. And then I have to still implement it. And then, oh, actually, that's nonsense. Must be like that. So we have a matrix again of the being the result. What's your return result? Now might as well copy the original, and then we're going to do the result dot all of them multiply with the scalar. Right. No, yeah, well, I don't know. I can't think of other things yet. Oh, printing them. Yeah, nah. It's not print matrices. Yet. Anyway. I think we have a matrix all in line. Great. Should compile. Nothing happened. Shocking. Why? What? This thing lives on its own. Confusing. Oh, I never saved this. Okay, added the matrix here. Yeah, we should probably include the header then. Vector and now a matrix, which already includes the vector, so I'm going to delete that one. And that should then compile. Brilliant. And well, not using it yet. What are we going to do with it? I'm kind of working with P0 is always the origin. I refuse to rotate the origin around the origin. That would really look silly, but then you start to wonder, why am I using P0 at all? Like here, I'm adding the origin to something which doesn't do anything. Might as well not add it. So at this moment I can still change the coordinates of P0 and everything works. If I now do not rotate it because I have hard-coded 00 in it, then I think I should remove P0. Or I have to rotate it. So I can still change the coordinates if I want to. Going to remove it. Although I'm using it here. Maybe it's safer to remove it. Yeah, I want to remove it, really. So, okay, and then I still want to create a point, of course. I think that should accept. No, it doesn't. Well, maybe it does. Create point. Do I have to finish my sentence or not? That's it. Yeah, I thought it was allowing two doubles, but it would be silly. Because you can just pass those like that. The origin. And now we don't have P0 anymore, but plot P0 exists now, which is yeah, derived from point. So it can be used to replace it. And then here the question is, of course, do I really want to? No, I don't want to use it anymore. And this works as well, because this is just an explicit construction of a vector from a single point, which then uses the origin as the other side. So this is just a vector from the origin to P1. And maybe I should not use it. Call it P0, P1, but let's call that history. And then we have this one. I'm going to remove P0 as if we don't have P0 anymore, even though we have plot P0. And then here I can remove it because it's just 0. How many other P0s do we have? Here's another P0. A line through P0 and P1, create a line. That looks like a point to point, so I really have to fill in the origin here. I'll just use plot. Or could use a direction actually. A direction vector. That was it. All the P0s we had. Okay, now I got rid of P0 so I don't have to rotate it. Yay. This, however, I'm going to rotate. And I'm afraid I'll have to rotate it before we plot it. So P1 is it's not easy. It's not really P1 anymore then. It's a rotated P1. And it's a vector afterwards. So rotated P1 is R times P1. And that doesn't work because I have to convert this to a vector explicitly. And that returns a vector. Create point from a vector. Can we create a point from a vector? That's the question now. This is a point. Create point. I think I just did this. Yeah, can only create a point from a point. Well, maybe it has a point there, but then I want an easy way to convert a vector to a point, otherwise I have to scream. Well, not really, but my vector allows me to get an x and a y from it, convert it to a direction, convert it to a point. Yay, okay, well, that's good enough. So I'll just call point on that. So we have the row. Wait a minute. I'm gonna make this a point. And we just have this and then turn it into a point again. It's really ugly, I'd say. But yeah, cannot allow automatic conversions, I think, in this case, from vectors to points. So I'm neither allowing automatic conversion from a point to a vector, otherwise you just could leave this out and it would do it automatically. And I also don't want to allow conversion from that vector to back to a point. Otherwise you could just say point is r times point. But I don't think that's worth it, because you might accidentally then convert points into vectors and stuff like that. But yeah, rotating a point around the origin, I mean... Okay, P1 rotated P1. Let's write our text in the neighborhood of that. And then we have here, draw a circle around, yeah, sorry, but we are working with rotated stuff from now on. P1, 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 no P1s, very good. Oh, here's another P1. Yep, that definitely has to be the rotated or rotted P1. I think this should compile. Let's see if my P1 rotates. It does not compile. No viable conversion from vector to point. I know. And that's exactly why. Oh, wait a minute. This used to work. Why would this work? And then I made the changes that I did and suddenly it doesn't work anymore? That is so weird. That does not make any sense whatsoever. Huh? What? Unacceptable. Investigation required. Git status. Loads of stuff, but not really. Just a matrix was added. No way that can make a difference. Oh, that's the reason. I removed the P0. Yeah, okay. I had point plus vector is point. But if you remove the P0, then suddenly it doesn't work anymore. Apply or... Pop. Does pop apply it? I think so. It better. Modify it again. Okay. Phew. Empty stash list. Yeah, now I finally get it. Because my memory didn't tell me that I just removed the P0 there. You idiot. Then we run this and we see a rotated P0, P1. That seems to have worked, except that I thought my theta started at 0. What the hell is going on? What? It's almost funny. Almost. Definitely changing theta. You definitely did not rotate P1 correctly. Not even close. What is going on then? Yeah, I mean, I start with theta is, J is 0, theta is 0, cosine 1, sine is 0. This should, but it isn't. I inverse these two. Blip. And nobody warned me. So disappointing. I'm also not looking at shit, by the way, but now I am. Yeah, nobody said anything. So, I think now it works. Now it just works. I know it. That was it. Now we have no rotation, and if I hit enter, P1 is going to rotate clockwise. Yes. Brilliant. Well, we have to rotate the parabola as well, of course, because now it's not going through P1 anymore. It's going through the P1 here. But we rotated it away. Escape. Okay, so we also have to rotate this thing here now, which means I'm going to construct a vector. How shall I call it? V. Brilliant idea. I'm proud of myself. T. So. And then we're going to rotate that to another vector maybe. Nah, let's just assign it from R times the vector that we create temporarily there. And I don't want it to look like a function. And now we have V instead of whatever we had before, X and Y. So we're going to print the values of X and Y, or V, dot. And also pass them like that. Because my curve is only taking 2 doubles. Okay, yeah, I think we're missing here something. Probably should take points as well. What is curve points anyway? And place back. Now I'm having the feeling that it are points. It are totally points, man. Okay, I'm still using and place back because we're constructing a point from. Nah, I'm going to use. Doesn't even matter, but let's use pushback. V dot point. I think that's it. So now P1 rotates and the parabola stays upright. This so has to be a 3D image. Can you see it? Parabola is not changing, it's just rotating. It's 3D. Which should give us all the insight we need. Or not. Yeah, so what is next? Next, I have another point. And we want to probably go through that. But that point is also rotating. Ah, talking about evading. If the other point was just a fixed point, that would be easy. But no, it's fixed relative to P0 and P1. So we have another point, and that's rotating as well. Let's just start to, work with this. I'm gonna call this point, I would like to call it, I don't know, it's a negative thing. Negative T point. So it's not P1. I mean, P0 is for T is 0, P1 is for T is 1. And this is for some negative value of T. So in my README I already call it P beta, where beta stands for the B of before P0. And I want to call it minus beta because that didn't look correct. It didn't look right with the UTF monospace subscripts. You get a minus and then a long time nothing and then a beta. So yeah, if I copy that from the README, then we have beta at the bottom. Yeah, P beta, that's what I call it. So PhD, that's interesting. P beta. P beta. A point at t less than 0. And then I guess I'll have to call it P beta cry. But the original P beta, just like here, I'm just going to give it coordinates relative to, the unrotated case first. Which means that we have to think of something. Let's say minus 1.0, comma, who cares? And then let's draw it in. Rotate it, search for P1, replace it with beta. Why not do that automated? Because I want to have some time to think or something, maybe. I don't know. I'm actually thinking about what I want to eat. If there is something in the fridge to eat. So maybe I should have used the subscription, search and replace, I mean. The subscription came out of it because it's, S. And then I don't know, my brain is weird. I'm just turning senile, I guess. Really weird. Substitute, that was the word that I was looking for. Vim substitution, that's what I should have used. And then this thing can be called subscript beta. This is absolutely, certainly part of the toy font of Cairo. Maybe we should try that out first. 1, 2, 3, 4, 5, 6, there it is. And there it is, including beta. Why did I put it so far away? No, let's put it closer. In fact, I want to have a completely curve, like I'm gonna put it like there or something. A half one. Nah, okay, hear that. Let's too symmetrical this. A little bit over 0. Yeah, well, maybe not. I don't know. Anyway. Yeah, well, no. I mean, it doesn't really matter, does it? Let's say a quarter one. A quarter 3/4. Diddling, dun, 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 dun. A quarter 3/4. No, yeah, no. I want to say quarter, no, it's at minus a quarter. Didn't see the minus sign. Chat TTP, someone? Talking too much with chat TTP. Finally, it's where I want it. Okay, so now rotate it. Yeah, it does rotate along. Great, isn't it? And we want to find a point where it's part of the solution that comes out of P0. So somewhere here. I think I already passed it, but oh, there it comes. Maybe it didn't. Exactly. I'm not gonna hit enter again. So this is it. This theta is the solution. And now the question is, how do we find it? And then I think it's gonna be hard math again, because yeah, just delete the window. Let me just type something in the README. Some people write diaries to comfort themselves, or I don't know. Yeah. So I have now a point P0 at 0, 0. Going to repeat that. I just got rid of P0. Ah, fuck. This P0 here. 0 is 0, 0. And I mean comma and a 0. And then we have a P1 which is at 1, 0, but then rotated. So that becomes I rotated it with minus theta, didn't I? Yes, theta was positive, and then it goes down, so clockwise. But that's still a cosine. But even more small theta, you see what it should be. Minus theta, because we go down. Minus sine of theta, I mean. And now we have a P beta, which is, and then we start with, oh, that's a complex thing, unfortunately. Because this one is then in R times xy. I can do this for my head, I'm sure. X times cosine theta plus y times sine theta, comma x minus x times sine theta plus y times cosine theta. Yeah, because the top row is cosine, cosine sine, and then below that in the matrix we have minus sine cosine. I'm sure of it. I don't even have to look in the code. just doing that to show you. You should not doubt me. Why are you doubting me? I'm not looking hard for my matrix. There. Cosine sine minus sine cosine. Right, and then the question is, of course, how do we find the parabola? And this time the parabola is just upright, so my god, it's a normal parabola. Like ax squared plus bx plus c, and even better, there is no c, because it goes through the origin. And so we can solve the equations just using these two. I already put that one in, that led to c equals 0. I'm not sure, maybe I should write this as ax plus b and then multiply the whole thing by x. I'm in math mode, you know. Sometimes I type stars, but now I'm going to delete them again because I said I was in the math mode. Spaces is multiplication. Not coding, it's a readme. Why is that? Let's fill in this point minus, that's y, the y coordinate, equals a times x plus b, and then again times x. And on the other hand, we have this horrible expression, but x and y are constants here, equals a times this plus b times again times that. Those are the two things that we have, and that should give me a theta for some given of I already have an a, right? I should not have used a here. Can I use C and D? At the top I'm using C and D, but it's probably dying out very quickly. 6%, yeah, and then again it's, oh, here we do it again, and even with A, B, and C. My God. No. Maybe I should not have used A elsewhere. What I started to use a, oh, where actually? Maybe just in my program, or I think with ChatGPT, and then I moved it over to Mathematica, and then copied it to my code. Let's have a look at the code. Do I have a? Yeah, we have an A here. used here. It's not very impressive yet. Probably should change this A. It's the newest A. And it's now nice to use A anyway, if you talk about it in English. What does this A mean? Nothing really. I don't know. Things used to have a meaning. Like W and S and V. Now I have an A that is, what is it? Oh wait, I have actually here a V. Hello, Rudini. I have hundreds and hundreds of videos, all of which are not me explaining anything, nothing to learn from it, in the sense that they are not videos intended to you know, compress something into a video so people can learn from it. It's just me working. And then there are people that are here watching like every day. I'm not sure if they're really watching, but at least they're tuned in, and maybe they work themselves. They might pick up my programming style here and there if you watch long enough. But otherwise, it's a lost cause, yeah. And I would like to explain to you what I'm doing, but I have such a bad experience with that. Really bad experience. Over and over and over. So I hope you're not mad, but my feeling is that if I would explain it to you, that you would silently leave after 5 minutes and then let me talk half an hour against nobody. I can say it in a few sentences. I would not waste too much time, I guess. Currently, I'm trying to find a way to what is the word? Fit is the word. Fit a Bezier curve through data points. And I'm starting with a quadratic Bezier curve, which is a rotated parabola. And I did a coordinate transformation so that my first point is in the origin, the second point is in 1, 0. So that would be a rotation and a scale. If first to translate, then a rotation and a scale to get the second point in 1, 0. And now I'm adding the third point. And then I lost 2 days because it's just way too difficult, like fourth degree polynomials that have to be solved. Now I'm trying a new approach where I rotate the picture of the 1, 0. And then my parabola is at least straight up. But, you know, where's my thing? So, yeah. So, this is unrotated, so let me rotate it a little bit. See, so the parabola is now straight up, just like a normal parabola. Y is function of x. And I'm rotating p instead of the parabola. But the coordinate system, the original coordinate system, has p0 somewhere, but the translation is not important at all. So p0 was here, I just bang, moved that here. And then we scale must be an what's the word? An affine transform. So we have to scale x and y the same. But I would just, basically you have to scale x and y, so the whole thing, by dividing everything by the length between P0 and P1, so that the length between P0 and P1 becomes 1. So this length is now 1. And then we still don't know the rotation really. But you can draw a circle through P0 and P1 like I did here, which now has a diameter of 1. And then you can generate parabolas by choosing a point on this circle. And then the line from P0 to that point is perpendicular to the symmetry line of the parabola. So in this case, this is the point. Because it's vertical. The symmetry line is now always vertical. So perpendicular to that means horizontal. So you have to, it's always a horizontal line from P0 to this point here. And then that length is proportional to the width of the parabola at a height of 1 from the vertex. Don't ask. I've been at this for a few weeks now. And then the other distance from here to P1 says something about where the vertex lays with the relationship to P0 and P1. So that's how I can actually draw this parabola. Yeah, the whole thing is just very complex. So even I don't understand it. So I think I just should continue, and then everyone is on the, what's the word? On the same dot, because nobody knows what we are doing. Yeah, well, no, maybe I'm not a mathematician. I did physics. I know some mathematics, but it's just linear algebra with vectors and matrices and in products of vectors and stuff like that. No higher math at all. Well, I don't call that higher math. I think it's high school math, isn't it? No, maybe not. First year, maybe linear algebra, first year university. So this is my C++ code here, and I have a point P0, which is the origin, so I don't even have that anymore. And then we have point P1, which is at 1, 0. And then I rotate it using R, where R is a matrix using that theta, which is random. You know, I can loop over it, different values. And then we have another point, which I just randomly picked to be here. And then, yeah, the whole thing is rotated. So to plot it, I also rotate that. And now the question is, what is the right theta? So what should the rotation be such that it is a fit? It's not fit now. The point is here. The parabola is not going through that point. So we have to rotate it, and I don't want this leg to go through it because that's for the wrong t values. You know, this leg must going through that point. That's my demand. So I just ignore that pass. Continue rotating. Oh, no, it sweeps to the other side. There we are. Plop. Yeah, now it goes through this point. So this is the rotation that I want to get. But the picture's not helping me, so now I went to the README, and now I'm doing math here to find the theta. And the equations we have is, well, I know that this is in 0, 0, even after rotation. This is P1 after rotation by theta, and this is P beta, the other point. when it started in XY and then is rotated clockwise by theta. So these are the points, and these 3 points must be part of an upright. So just a normal y is a function of x function. And because of the 0, 0 here, we don't have a c. It's just if x is 0, then y is 0. But these two, if you even trigonometric function in it, cosine and sine. So I fill those in this formula here, and we get that. And what was I doing? Was renaming A, wasn't I? Did already figure out what A I wanted to do? Oh yeah, I want to do, yeah, that's what I was doing. And then you came on the channel. Well, I was looking here and I wanted to rename A. And I was wondering what is A, and the only thing that I know is actually it's this. So I don't know what A is, but I know what V is. But yeah, that's hardly a nice relationship, so it's kind of a random thing. Let's call it H. No. H I J K is integers, huh? L M N O looks like a 0. P looks like a prime. Q, nah. R, nah. S, nah, already used that. T, already used it. U, yeah, UV is also something usually different. Already use a V, don't want to use a U. And then X, Y, Z. So then none of the, that's why I used A. There's literally nothing left in the alphabet. It's not a scaling factor. At most, I can compare. I mean, I can do one more attempt. Compare with this. Here I have. I know what more or less S is a scaling factor is, and V is this. Where is the vertex variable? And W is the width of the problem. So if we compare that with the thing that I have now, then you see that you just pick the simplest. A is fucking the square of S. Is that true here as well? Well, not quite though. Not quite. Why not quite? It's like V is a half. Don't tell me V is a half. V is not a half. I lost V. I do have a relationship between V and I know what I'm doing. I don't even know how I called this anymore. Pure horror. I was working on that README, and then at some point realized, pretty near the bottom, that after all that work, we should actually have something that is a function of two variables. So here we have S, W, theta, and V. That's 4 variables. And then we introduce P0 and P1. And after that, there should be only 2 variables left. Well, P0 is always there, so it's more like the X and Y coordinate of the point P1. It should replace 2 variables. So, and then I made up something. I say, well, let's keep the rotation, and then this looks just looks simple. Why make it more complex than just have my other variable as a multiplier of those things? And the one, no doubt, is the distance related to the distance between P0 and P1. Because I put them. This is also in the case that P0 and P1 have the same y coordinate. Yeah, so this is with P1 at 1, 0. This matrix. Otherwise, it becomes way more complex. So I think the A has a meaning. Ah, that's it. Yeah, no, of course. Finally, I see it. This A has the meaning of S squared. But since P0 and P1 are both on the y equals 0 line, horizontal line, that means that V is a half. If you compare them. So it's really complicated. I think I'm just too stupid, really. It can't be complicated. I just say it's complicated because I don't get it myself. I think that's definitely I mean, V is a half if those 2 points are both on the same line perpendicular to the symmetry line of the parabola. So that's why I think the 2 and the V drop out here. Okay, and S was a new scaling factor between the distance between P0 and P1, which I know set to 1, which gives the ratio between what I call the width of the parabola. So it's, I guess, the reciprocal of the square of the width. What is the square root of the width? This is 1. I guess we have to, this theta is I think a different theta than that theta to make it easy. I think this theta must be set to 0. So this is 1. So if then this is 1, then this is 1. So the width is 1 divided by S. And A is S squared. So that makes it W, well, A, yeah, A is 1 over the width squared. Probably. For which I can't think of a good name. Because it's not even the inverse of the width. It's the inverse of the square of the width. What name could you give that? Maybe I should use more than one character. Okay, so it's the reciprocal of the square of the width. Beautiful. Oh, that was sarcastic. But let's use it. I really hate abbreviations. Like really, really, really bad idea to use abbreviations for your variable names. But this program is different, you know. It's not really, it's a test program to begin with. I'll just add a comment. then everything's solved, and I can call it RSW. This is the probably, yeah, it's exclamation mark, the reciprocal of square of the width CW in readme.bezier. And I don't really care what it is, because it's just my second variable. The second variable that generates my curves. So now I have to replace this with reciprocal of the square width. RSW. RSW. Well, if this compiles, then it probably still works as before. Yeah. Okay, we took the load of A. So now I can write yx is ax plus b times x. Fill this in. And then solve it. Piece of cake. Let's say I have two equations, and this is a variable which I want to solve, I think. And, or do I want to solve A? Yeah, we have two variables. Ooh, wait a minute. I want to get rid of these, but then compare them with the ones that I have here. Oh no, that's something else. And the ones that I have in my program. It's probably also not correct anymore. It's using the old formula. Yeah, it's including. Yeah, no. This x is actually that 1. Maybe I should fill that in like that. But then I keep copy pasting all the time. Might be more clear. Especially since I have an X and a Y here. Yeah, maybe that was not a smart thing to do then. Although I replaced this X and Y again. Okay, so we have a sign is up, and this then is that X, which now has to be changed. Y. And now we can't paste it anymore to Mathematica, because there's all kinds of weird stuff here. No. I think I want to get rid of this A and B, or at least express them in the rest. Probably that's what I want. Huh? So we have to solve A or B and then fill that in the other. And now we get a mess again. A huge mess, but at least then I can write this one down. So yeah, it's gonna be huge. I should use Mathematica for this, I think. So I went back to XY. At least now I can paste it in Mathematica. Yeah, no, that's right. See if my Mathematica foo has increased since last times. I probably should just start a new stupid thing. Almost erases itself. Even if you don't look at it and come back, it has forgotten everything. No, might as well click on this then. Start all over new. Okay, let's. I think it's, I don't know. How shall we call this? Let's make it an equation. And then there's the one that comes from here, which comes from here. So it's kind of a one thing. Let's call this equation 1. And we define a function maybe. I'm going to define it as a sign plus that. So bring it to one side. So if we set E1 equal to 0, then we have this. Yeah, then we have what we had. I don't know how else to do it. Yeah. So add equation 2 in it, and that's not the same 2, but after 1 comes 2, which then should be this one. So let's do the same thing. I'm gonna do this and then bring that to the other side. No, does not want to do that. So that would be this, and then we subtract that and add that, or the other way around. Plus x sine theta. What the fuck? This thing moves my cursor. I have to paste it here. That's so stupid. Kill Bill Gates. Kill Bill, I mean, that's a movie. X sine theta. I think he invented it. It was a Microsoft thing, isn't it? Yeah, must be. X sine theta minus, yes, thank you very much, minus this, And then a precise here, RSI, rupture stress injury, and then paste. Okay. Now shift enter. And then there's a lot of white space here. Oh, these things, we can delete that because they don't exist anymore. Probably have to repeat this. Okay. Now what to do with it? Because I moved this over and I have to set them equal to 0. Okay, we just begin with the first one. So I'm going to say solve E1 equals 0 for theta. No, for A. Actually A or B, you know, like. Which one looks better, maybe? Solve E1 equals 0 for B. They both look horrible. How does this have a theta and those don't? Sine theta, cosine theta, cosine theta, cosine theta, sine theta, cosine theta. Those are not sines, those are variables. Great. Great, great, great. You have to make it as a capital S. And this, and then it's almost as bad as the old VI. Type one thing wrong. It's 2024 and I have to do this by hand because Mathematica did not understand that I meant cosine theta, and I'm forgetting the capitals, the upper cases now. I'll do that afterwards, I guess. I could have done it faster by pasting it again and then doing the replace in new Vim or whatever. This must be a capital, this must be a capital, and this must be a capital, and this must be a capital, and now a pop-up should appear. Do you want me to replace all the others as well? I see what you're doing. No, it doesn't say anything. Okay, we're done. Yep. Shift enter. Now it knows. Shift enter. Oh, it looks even better. Looks simpler. That one is the same. Let me think. Let me check it rather. B plus the tangents of theta. There's a minus involved of it. Solving A. So that's minus sine. Minus the sine of theta. Minus B times the cosine of theta. Divided by the cosine. I don't see it, but I suppose it's okay. This is Mathematica. That doesn't make mistakes like ChatGPT does. B should be easier though. So minus sine divided by the cosine. The cosine is 0. Yeah? You get the tangents, minus the tangents. And then we subtract a cosine theta. Yeah, then you have b. Totally. And the other one is now easier to see as well, because we add b. Sorry, we had a plus. B plus the tangents. Oh, the minus in front of it, yeah. So minus 10, the minus b. And then you have to divide by the cosine, which means multiply with the sec. Good. Check them both, they work. Now what is the next step? The next step is then to replace one of them in the other one here. I'm gonna replace b, very randomly. Let's define b as this, which I can't copy, so I'll just type it over. Minus a cosine theta minus the tangents of theta. B has been redefined, so if now I ask for E2, you get something with no B in it, because it replaced B. Oh, I don't recognize this anymore, but okay, B is gone, so I guess it's good. And then we can ask to solve E1 equals 0, and now of course a, and that would be that. What a nightmare. What a horrible nightmare. I guess I have to. This so doesn't look like a times cosine. It looks like weird, like it's like a single thing. Yes, I typed this space. Yeah, that's my input. Oh, this is also my input. Oh, gotta put the space here just in case. See, that made the change of cost changed. The color of cost changed. I think this is a significant thingy. Oh, that didn't change. Anyway, that did changed. That changed, I mean. I think that's better. What is better? Oh, it's still a nightmare, but I don't know. What else can we do to convince ourselves Nothing. Well, I could put this in my program, I guess, and then we have an A and a B, or rather we have an A, and then with that we have even a B, and then we can draw that parabola using the A and the B, and then check that it is indeed the same thing as I already have. But let's assume this is correct. Then I want to define, why not A? Again, or I don't know how to do that. Do I really have to type all that? Mathematica convert output of solve to a function or something. How to create a function directly from the output of solve. Two of them, and I want this something. Answer. Clear all source is solve. X11. What? Okay. Blah. It's a function of stuff, it says. The A is all cylinder. Yeah, there's an A in there. So we have a function of x and y and theta. And that's it. And that is of course A. Maybe it's not smart to use here A here. I'm gonna call it a function or something. Slash dot. Oh, we don't have a source. Can I interrupt this with solutions equals, or do I just one solution? Solution. And then here we can type sol. Now, what else than one? It seemed to have worked. No, I don't really define a b function, which should be also a function of x and y and theta. And equal to let's skip this one. I think I have to clear B here first, probably. Let's delete this thing. And this is solution B, which might not work. Yeah, it actually did not work. Unbelievable. Let's type in clear. Yeah, A comma B, I don't know. If I just clear B, I have to clear A as well. Duh. And now? And it works. That is because we needed clear. So then now this is equal to the cleared B. With the solution of B. It's like learning Chinese. Okay. How does this help me? Some example values would be nice. I have to go to bed though, it's 1 AM. I'm still not clear about what you do. You know, I'm building my sentences as usual. At least I used to do that. I'm really feeling like I'm getting senile, right? I mean, memory degrading and stuff like that. But in the past, I used to be a special guy, and I was aware of building my sentences while pronouncing them. And usually I would like start with a keyword and then work my way towards it, or sometimes just an idea of a word, work my way towards that word, and then by the time I got to the word, I would have found the word, so I could just continuously speak like that. And at some point in my life, like less than 10 years ago, it started happening that I just could not find words anymore in time. First, I couldn't find them in time, so I was mid sentence. I would stop talking, but yeah, well, just couldn't find the words in time. And then I couldn't find words at all anymore, so I just stopped mid sentence, and I had to say, I don't know what the word is. I'm looking for a certain word, but I can't think of it. And now you see things like, I often see that I want to say something, and at the same time I'm looking at my screen, of course, and then I kind of automatically pick the same words as I see on my screen. You probably have noticed that already. I can't even remember anymore, but just now I made a sentence with the word clear in it, because it's on my screen. And the whole sentence made kind of sense, but why would I pick a word, why would I pick a sentence with the word clear in it? Today I was kind of joking when we were talking about points. Then I said, I want to make a point of it or something like that. That was conscious. That was just, all these points. So then I don't know. It also happens unconsciously. And then afterwards I catch myself on it. So I say, I did it again, I just made a sentence. And the sentence has a certain word in it, and the only reason that might have happened or seems to have happened is because it's also on the screen. Kind of like I would continue like, well, this is a problem for me. I don't know how to solve it. Why? I mean, that sounds like a genuine remark, but then apparently the only reason I say it is because the word solve is on the screen. The brain works in mysterious ways. Anyway, I'm going to bed. Let me be clear about that. That was also deliberate. Definitely, that for sure. But now you're comparing me with people in the 50s. Plus, old folks. Hello. Even in my senile state, I just did another Mensa test. Well, it was an online one, but still. And I was not really into it. I just did it, and I still scored 99.5%. I think my official Mensa test was 99.9 or something. But or even higher, I don't know. I don't feel like that is the case, except that it might be for certain things. The point being that saying 99% in your sentence is kind of trivial, obvious. Yeah, of course. Let's start with the top percent. If you say sharper than 99.99%, now then that would be a compliment. Yeah, I'm comparing myself to my previous self, I guess. And I think it's mainly my memory that's bad. Like, I mean, I don't know, man. It's just sometimes I can get really irritated about what other people do, and if you show that, then they get irritated. For example, so my parents are living in a nursery-ish home. It's not exactly like that, but and I need more room next to the bed of my mother because she can hardly move anymore. So they're going to use some kind of bed lift thing. How do you say that in English? At least it's some kind of apparatus, and they need more space for that. So they asked me to move a piece of heavy furniture, or even source parts of it. And I really hate that, but okay, there's no other way. So I went there with all my tools. And then there was one of the people that actually because it was communicated to me by the boss, of the complex. And then I talk with the people that actually have to put my mother in and out of bed. And I just know that nobody does what I then do, namely openly discuss everything down to the details, right? I don't know. Normal people don't do that. They just swallow everything, and they don't. I don't know why, but every time when I say something that is a critic, I pointing out a flaw somewhere. For example, I cancelled my subscription with the library here, and I explained to them why I did that. And then, of course, she said, "You are the first one to complain about that." That happens so often. It's like, yeah, I'm the only one who says it. The rest is just not a member here, or not anymore. She actually stayed nice to me. I think in the end, she agreed. But okay, so in this case, I talked with the people that actually have to move my mother in and out of bed. And I got out of them that the solution that the boss of the complex wanted to enforce, or, like, this is the solution, do this. That is not a good solution. They said, well, if you do that, yeah, then we still don't have enough room. So then I said, well, then I'm not continuing with doing that, because it's probably, I see that too, and you admit it now, not a solution. Now, so they went back to their boss, and the boss makes contact with my brother. He doesn't have my phone number, thank God. And my brother communicates back to me that now the story, it's like the whisper game. You whisper something in someone's ear, and they tell it to the next person, and whispering and so on, and it changes. What came back to me was that my father was suddenly not happy anymore with the changes that had to happen to the furniture in his bedroom, and I would have been partially agreeing with that. And that was the reason why I didn't want to continue with the work. So I'm thinking, what? I never said that at all. On the contrary, I said, I am automatically agreeing with everything you decide, because I don't live here and I don't work here. I just want you, the worker, to be happy with the solution, and it shouldn't be so drastic that it makes my father unhappy. That is what I have said. And then they turned that into what I just said. Unbelievable. Worse even, this boss is so self-secure about I am right. He's like complete idiot, of course, but his solution doesn't work. I, in the meantime, talked with 3 or 4 different people that work there, and they all more or less agreed with me. I say more or less because I think they're really, kind of in the position like, yeah, if my boss says something, then I'm not going to go against it. But worse, they don't think for themselves. They think their boss is God. So if the boss says that it is a solution, then it has to be a solution. But then if you show them, you say, okay, but you want this, so bed like that, then it's like this, except that the bed then will be possible to move 30 centimeters to that side. Is that enough? Yeah, and then they stand there and they see it and they said, yeah, no, that's still not enough. But you really have to press the face into it. Anyway, though, the boss makes contact with my brother again and he says, there is no need for Carlo and me to talk about this again because my workers, my English is not my first language, so I have to really search for words here. The people of the take care of your parents and me and you and everyone is agreeing with the solution. So everyone is happy. And that's just what has to be done. And yeah, he's the boss. So he is used to nobody going against him. Not only that, it's just in my character, to point out flaws in what people think of. So he's plus the boss, plus normally nobody goes against anyone who talks like him, so in the sense of self-secure anyway. And then I come along and I disagree with him because it's just not a good solution. And it feels like he can't have it. So today I was there again and I picked out his daughter. I thought, I'm not going to talk to the people that work for him because they're, that just doesn't work on the work floor. You can't disagree with your boss. You can't start an argument with your boss that basically comes down to, boss, you're wrong. But the boss didn't want to talk to me because it was his free day, and he just wants me to do it. So I talked with the daughter, and now I convinced his daughter that it is not a good solution. And then she's going to talk with him. So he's probably still going to be pissed, but at least he's not going to fire her because she's his daughter. Yeah. And then I realized that I'm not like other people, because I just know other people. They wouldn't have talked with anyone. They just would have done what they were told to do, and that was not a good solution. And then nobody would have been happy. Certainly not people that work there. But still, nobody would have talked about it because now something was done. This was what the boss wanted, and no. It's like so many places in the world, even what you see in politics or any company actually. People accepting solutions between fat quotes that are actually just horrible. And you ask yourself, my God, who thought about this? Is there really nobody thinking about for themselves anymore or something? Yeah, okay, so I'm going to stop the stream. What is on top of here? This thing, all logged in. This can be